Okay, so this is Unit 4, Objective 2, which is multiplying and dividing radical expressions. Okay, so in the Pearson book, this is actually 6-2, which starts on page 32. So Pearson 6-2, which starts on page 432. So that's for reference. So when you look at your book, you can see that. So just in general, as far as a couple properties that we need to know in order to simplify our radical expressions when we're multiplying and dividing, is for multiplying, so for property number 1, so this is for multiplying and dividing. Let me focus this just a little bit. Is when we're multiplying two roots together, so regardless of what root we're working with. So this could be the square root, the third root, the fourth root, and so normally we would put an in here, but we're just looking at square roots for today. That when we're multiplying these together, we are just multiplying what's underneath. Okay? And if there is a number in front, then we would multiply those front numbers. So, for example, we'll just do a couple quick ones here. If I have the square root of, say, 5 times the square root of 2, that would just be 5 times 2, or square root of 10. Okay? But if I had a number in front of that, say I had 3 root 5 times, 2 root 2, then I multiply the 3 and the 2 together first, so that would be 6. 3 times 2 is 6. And then I would multiply the square root of 5 with the square root of 2, which would just be the square root of 10. So that's just that first property. And that's true for division as well. So the second property that we're going to look at is, what if I am dividing? So if I have A divided by B, I could rewrite that as the square root of A over B. Okay. And so that is the same idea. And so then just two little examples here just to kind of make sure we understand that. So if I had the square root of 6 divided by the square root of 2, then that's the square root of 6 over 2, or the square root of 3. And also, let me put an A on here. If there was a number in front, say we have 12 root 6 over 3 root 2, I would do 12 divided by 3, so what's out in front, which is 4, and then the square root of 6 divided by 2, or 4 square root of 3. Okay, so those are our two properties that we're going to be working with in order to multiply and divide. So we need to know this and that. Okay, so let's go ahead and take a look at a couple of examples here. Okay, and we'll be using some of our lesson 1 in all of these problems as well. So for the first example, we want to just simplify. Well, that's actually the directions for all of them, so we're just going to simplify. And so this is the example on page 434. So if we have something like this, so we have 45 times 35, which that would be really difficult to do. So when we have large numbers, what we want to always try to do is simplify first. If the numbers are small, like say if that was 4 and 3, then I would just, I could just multiply those together pretty easily. So the first step is, if the numbers are large, we want to try to simplify the radicals first. So again, that's just if the numbers are large, we want to simplify first. Otherwise, let's just go ahead and multiply, so we're not trying to juggle too many things at once. So if the numbers are large, we would simplify first. Otherwise, we would multiply, okay? So for us, when we look at this, I know that 45 breaks down to 9 times 5. But 35 does not, right? 35 doesn't break down to any kind of number. So that's 7 times 5, but we don't know the root of 7 or the root of 5. So then I do know the square root of 9, which is 3. So I'm going to make that be 3. And I don't know the square root of 5, so I'm going to leave that as the square root of 5. So square root of 9 is 3. I don't know 5, so it's going to stay under the radical. And then I'm going to keep my variables the same. Again, because I don't want to juggle too many things at once. And so I'm just trying to make what I multiply together here smaller. Again, I don't have to do that first. I can just multiply first. So I'm just simplifying this. So now that I have that done, now I'm going to multiply everything under the radical. Okay, and then just a little reminder, we add our exponents, right, when we're multiplying. So just a quick reminder. Okay, so all I'm doing is I'm going to multiply. So if there had been a front number here, I would multiply those together. In this case, I'm just multiplying my radical terms together because there's nothing to multiply with the 3 other than maybe an implied 1. So the 3 is going to stay on the outside, so that'll be 3 times, again, 1. And then I'm going to multiply 35 with 5. And if I can't do that in my head, I would just do it over here, right? So that's 150 and 25, so 175. And then add my powers. So there's an implied 1 here, so I have 5 x's here and 1 more, giving me a total of 6 x's being multiplied together. And then I have 3 y's and 4 y's, giving me a total of 7 y's being multiplied together. Okay. And then now this is where I'm going to use my previous objective. So I'm going to simplify. So what I'm looking to see is what numbers multiply to 175 that I know I can take the square root of. And so I know I can do 25, right? So this is going to be, I'm going to rewrite this. So 25 times 5. How about not times 5? How about 25 times 7? So how I figured that out was I know 35 is 5 times 7. And so I have a 5 and a 5 times 7. So 5, 5, 7. So that's 25 times 7. And then x to the 6th I don't need to split off at all because it's an even power. But I need to split 1 off of the 7 on the y, so I need a 6 and a 1. So a lot of you will try to skip this step to, hurry through it, and if you do skip that step, it does tend to make things confusing and you end up putting things in the wrong place. So all I'm doing here is I'm rewriting this and I'm not simplifying at this point. All I'm doing is breaking things apart so that I can simplify. So I don't want to hurry through this step and then end up making a mistake elsewhere. So for here, the square root of 25 is 5. So I have a 3 already there. I can reduce 25. So I'm going to put a little check to remind me that I pulled it out. And then I can't simplify 7. So I'm going to circle it to remind me that it stays. I can pull out x to the 6th, so I can break that apart. And so when we do square roots, we divide by 2, right? So 6 over 2. So that would be x to the 3rd, little check mark. And then 6 divided by 2, so y to the 3rd. And I can't reduce that. And so then everything that's circled, the 7 and the y. Okay. And then the last step, whatever I can do that I pulled out to make that look better, I would. So 3 times 5 is 15. And I don't need all the implied multiplication, or I don't need all the dots for multiplication because side by side is implied. And so then I have 15x to the 3rd, y to the 3rd, and then the square root of 7y. Okay, all right, and then let's do one more multiplying. Okay, so this is another just multiplying problem. Okay, so it's the same kind of step. So in this case, I have nothing to multiply the 3 with, so that's just going to be a 3. And then I'm not going to try to simplify this because these numbers are small, so I'm just going to multiply together. So the 3 goes with the implied 1, so that's 3. And then everything under the radical gets multiplied together, so 2 times 10 is 20. I have 2 x's and 1 more, so that's x to the 3rd. And then here I have a y times a y, which is a y squared. Okay. And then also just a quick reminder here, because I just noticed I have a y squared here, and I want to make sure we don't think absolute value of y. So y to the first, so in order for this to be a real number and not imaginary, y would have to be greater than 0. So this is already, we know that y is positive because it's just y to the first, so when I try to simplify y squared, I won't make it absolute value because this is y to the first, so y is already greater than 0. Okay, so multiply, and then now 20 will break up. So now I'm rewriting, I am not simplifying, right? I'm rewriting. So 20 is the same as 4 times 5. Don't skip this step, right? Because if you do, you tend to pull things out that don't belong out. I need to break off one of the x's here, so I have an even power. So I have a squared and a first. And then y squared is fine. So 20 is 4 times 5, x to the 3rd splits up to x squared and x, and then y squared is fine, right? So the even power is okay, but when I have an odd, I always pull one off. So I have a 3 already here, so I'm going to keep that there. Square root of 4, I know is 2. I don't know the square root of 5. So the square root of x squared, we think, oh, absolute value of x, but it's not, right? Because I have an odd power, right, in my original problem, so that implies that x is also greater than 0 already, so I don't need the absolute value of x. This is an odd power, so I can't break it down. And then y squared is just y. 2 divided by 2 is 1, right? We take half of the powers. And again, it's not absolute value of y because it was originally y to the first. And so then that one's done. So the only thing that I didn't root were the 5 and the x. And then I can simplify this a little bit more, 3 times 2. And I don't need to have the dots. I can just write them right by each other as implied multiplication. And then 5x. Okay? All right. And then let's go ahead and do a dividing one for practice. So this is off of page 435, the example on that. Problem 4a. Okay. So we're going to use, let me go back to the properties here real quick. So we're going to use property number 2, where we're going to rewrite it as one fraction, and then once we do that, we can reduce it. Okay. Okay, so our first step is we're going to rewrite it as one radical. So if we have 2, we can rewrite it as 1. And that allows us to have just a fraction where we could just do normal reducing, okay? And so that's our first step. We're going to rewrite it as one radical. So this is the original problem. So I'm just going to rewrite it. And then once I get to here, I'm going to simplify. So I'm going to try to reduce the fraction. And then just as a reminder, when we're dividing, we subtract our exponents. So if I have 2 variables, oops, then I just subtract my powers, right? So as long as they have the same base, so in this case they're both base x, I would just subtract my powers. But in dividing numbers, we would just divide. So don't get that confused. So 50 divided by 2 is 25, but we're not going to do 6 divided by 4. We're going to subtract my powers, because this means I have 4 x's multiplied together, 6 x's multiplied together. So those 4 x's would cancel, leaving me just x squared on top. Okay. So I'm going to just divide those. So 50 divided by 2 is 25. And then subtract my powers. So 6 minus 4 is x squared. Okay? And then now I'm going to go ahead and simplify once I get to that point, using objective 1 ideas. So the square root of 25 is just 5. The square root of x squared, so I'm going to divide by x squared, or divide by 2, so 2 divided by 2 is 1. And I have nothing that's like odd powers or anything left, so that means I'm not going to have a square root left in the problem. So now, is this absolute value or not? So if I look back here, these are all even, right? Even powers. And so because they're even powers, x could have been positive, could have been negative, so therefore that means it has to be absolute value of x. Okay?